Hi folks, I just want to give you some helpful hints here on the tracker app. This is the incline plane. I loaded it up and I tabulated the data, collected the data, and basically plotted this thing out over here. Now, just some helpful hints. If you're seeing that the graph, for example, if you go over here to the graph and select velocity component here, you notice that it's kind of jagged. That's okay. That's your real data right there. But there's this little region right here where the object hasn't moved yet. And when you actually select the analysis for this whole thing, it'll also include this little bit over here, which may throw off your number for the slope itself. And so what you need to do is come down here to the timeline here, and you need to move this little black triangle over this way a little bit. So what that does over here, as you do so, you see that little gray box down there, move towards the region where you have motion starting. So let's start from there. And that way it cleans up the data a little bit more so you get a nice linear thing going on. Now the other thing to note, some students were asking, well, where the heck is the equation line? Here's what you do. You double click on here. A new box pops up. All right, and it starts to, it shows you the line that goes through, well, you'll have your data set there, all right. What you need to do is go over here to Analyze, and then do curve fit, all right. If you don't do the curve fit, this is what you get initially, right? So you want to select curve fit, and so boom, you do this, you get the line that goes through. The other thing that I mentioned in the announcement is that when you first get your data, it's going to show up with a bunch of lines connecting each of the dots. It's like a connect the dots thing. So you want to go over here where it says style in the graph here. You want to select this over here so that it is. Oops. Let's see. Style. Oh, why isn't? Oh, there it is. So there's the box there. And it'll give you some options here to select what you want. The lines are typically visible when you start out. So you may get something that looks like this. We have connect the dots and the linear fit going through the data at the same time. That looks really bad. You don't want that to happen. So what you want to do is unselect the visible, so you get your raw data set there and you get the line passing through, which is going to be part of your linear fit of your curve there. And then hit OK. So you don't ever want to use the visible lines in any of the data that we do for the labs. So we get this, and then down here below, in case you're wondering where the heck is the formula for this, you selected line down here. This is the default. You could choose other ones like exponential or cubic or whatever, but we want line. The fit equation is this y is equal to mx plus b format here for this, all right? And it's vx is equal to a times t plus b. And then over here, capital A is your acceleration, right? And so over here you take a look. This A parameter is 4.699 times 10 to the minus 1. So this will give you a 0.4699 value meters per second squared for your acceleration for this incline, okay? We're not getting 9.8 because obviously this thing is not going straight down in free fall. It's on an incline. And then B here is your y-intercept. This is essentially where this thing would cross the y-axis, okay, or the vx axis in this case here. So that number is given right here as 3.327 times e to the minus 2. That's not so important, but you know, this gives you some information about how this curve is how this line is passing through the data here, right? So so the number you're going to need, you know, to calculate the in this case here the slope, which is the acceleration for the velocity versus time graph, you want to use A here. This is your slope, 4.699 times 10 to the minus 1. And again, E minus 1 stands for 10 to the minus 1. And it also gives you information about standard error, which is this thing here in the blue box, plus or minus 4.8 times 10 to the minus 3. That's a standard error that's mapped onto the thing. What that tells you is that this value here can vary anywhere above and below by a factor of 4.8 times 10 to the minus 3. So this number could be this plus this number or this minus this tiny little margin of error here according to your your data here. And so that's part of the spread associated with the data. So if this were an ideal system, it would all be on a straight line here, but this is realistic data. You're eyeballing the data onto, when you're collecting your data, you're eyeballing it. So they weren't going to land exactly on a line like this, but it tends to be pretty close. But the amount of spread that you have in terms of your data here, due to the fact that you were sort of clicking on a blurred line, shows up right here as your margin of error. All right, your standard error that you see here. So that's that information. You could use that in your conclusions if you want to as well. All right, so that's the end of the video here. So thanks.